Let us now find out the peak inverse voltage of full wave rectifier. Especially first we'll consider center type and then we'll go for the bridge type. So we know half of the story. We have seen that what happens when the during positive half cycle diode D1 is forward bias, during negative half cycle diode D2 is forward bias. But we don't know what happens with D2 during forward bias, and what we don't know what happens with D1 during the negative half cycle. Okay, so let us consider, let us think over that. So we know when we are considering the positive half cycle, the point A will become positive with respect to point B. So what we'll get here, Vm, this thing we know that here we are getting the polarity of voltage like the Vm. This is also Vm and the polarity is like this, right? So due to this, what will happen? Diode D1 is forward bias, diode D2 is reverse bias. This I am considering in case of the positive half cycle only. So now we know diode D1 is forward bias. So as a result, what will happen? The current will flow like this in the upper loop. So what will happen? Here you will get the voltage drop across this resistor, and this voltage, as the current is flowing like this, that's why it will have the polarity in this way, right? Now what can be the value of this voltage, maximum value? So maximum value can be equal to Vm, because let us consider only the upper loop, this one. So in this we know what is the supply is having maximum value of Vm, and according to KVL the voltage will get divided into the two devices which are in this loop. So the voltage will get applied to diode and resistor RL, but we know the diode D1 is forward bias, so voltage drop across diode D1 will be very negligible. It can be 0.7, right? So that's why we'll neglect that. So where the remaining voltage will available, so all the voltage will appear across the resistor. That's why it is said that when the diode D1 is forward bias, all the voltage will get across the resistor RL. So it is nearly equal to this voltage Vm, right? So this is the case that we were knowing in case of the upper loop. Now as we are interested in the PIV, we should be talking about the diode which is reverse bias. So during positive half cycle, this diode D2 is reverse bias, and that's why some voltage will get applied across this diode, and this voltage we are calling as a peak inverse voltage, right? So now again we know we are going to apply the KVL in this lower loop now. Now forget about the upper loop, we are interested in the lower loop. Now we know the polarity of the voltage Vm is this. The voltage Vm is generated with this polarity already, and let us consider the PIV voltage having this, and we know as the diode is reverse biased here, it means its anode is negative, cathode is positive. It means that the polarity of this PIV I can consider like this. Okay, now let's apply KVL here. So if we apply the KVL in the lower loop only, so now I will start with this point B, will circulate through the loop and come back to point B once again. So if I flow with this, I will get, so here I am moving from minus to plus, that's why it's a Vm which is positive. Again here minus to plus, so again it is plus Vm. Then moving here, I have to move like this from plus to minus, right? And its voltage is PIV. So plus to minus, so it is minus PIV and equal to 0. Remember the Kirchhoff's voltage law. Algebraic sum of all the voltages in the closed loop is always 0. So that's why this is. So it gives PIV is equal to twice Vm. So it means that in case of the center type of full wave rectifier, the value of voltage which is getting applied across the diode when it is reverse bias is twice Vm. This was the case of diode D2 during positive half cycle. Now similarly you can consider the negative half cycle, and you can calculate the value of PIV for diode D1, and I am sure you will get the same value, that is PIV is equal to twice Vm. Now let us consider the full wave bridge type of rectifier working, all of us knows. Let us consider the condition when we are having positive half cycle only. So during positive half cycle we know the upper portion is positive, means point A will be positive, point B will be negative. It makes diode D1 and D2 forward biased, and if you remember, the current will flow like this. It will start from here, go to point A, then diode D1, then this resistor, then diode D2, point B, and back to the circuit. So in this way, the voltage which is generated here is having polarity like this, because the current is flowing from right to left. And we know the maximum voltage that can be available here will be equal to Vm, because we know the input is having maximum value of Vm. So that's why the maximum voltage which is generated here will be Vm. We are neglecting the voltage drop across diode D1 and D2, right? So again, we are going to apply the KVL in which loop? In the upper loop only. So this loop is actually consisting of uh, let me consider this loop only. Okay, I will this loop I am considering only, which is consisting of diode D1 resistor and this diode D4. It means I am interested in calculating the what is the voltage applied across this diode D4. So as we know, we are interested in the peak inverse voltage. Let me write here the voltage which is generated across this diode. Okay, that I will write here, that will be okay. So now if we apply the KVL in this loop, first of all I have to consider the potential. So diode, the current is means the circuit is here as shown in this figure. So let me consider the voltage drop. This is forward bias, so of course diode anode will be positive, cathode will be negative. This is reverse bias, so it means that its anode will be negative and cathode will be positive. That's why it's reverse bias. Now as we know, this is the positive half cycle, so point A is positive, point B is negative. That's why I'm writing here as positive, this is positive, this is negative, this is negative. Why this convention is like this? Because the current is flowing from right to left. So with this convention, let us apply the KVL. So now let's start flowing in this direction. So from Vm we can say I am moving from positive to negative end. That's why I am having minus Vm. Then again, for this diode I am moving from minus to plus, so it should be minus to plus, so it is positive. Positive, I will write VD4, means voltage across diode D4. And for this diode I am moving from positive to negative, so it's a minus, and I will write VD1 is equal to 0. Now what is VD1 and VD4? So VD4 is nothing but the reverse voltage which is applied across this diode, so that is nothing but the peak inverse voltage. So VD4 is nothing but the PIV, right? And what is this VD1? VD1 is the voltage across diode D1 when it is forward bias, so it can be almost 0. It is not actually 0, it is 0.7 because the diode is forward bias, but I will consider it as almost 0. So that's why I am writing minus Vm plus this PIV minus this is almost 0 at this 0.4, so that I can neglect, so that is equal to 0. So in this way I am getting the peak inverse voltage of the diode D4 is equal to Vm. In the same manner you can apply the KVL in this loop and you will get the PIV for the reverse bias diode. Now in this case the reverse bias diode is diode D3, so it is again coming to be 0, right? So let us go. So here we know that. Now let us consider this loop, which is the lower one. Okay, now in this, if I have to apply the sign conventions, the sign convention of Vm will remain same because the current is flowing from right to left. Now this diode D3, it is reverse bias, it means we have positive and negative here. This diode is forward bias, so this is positive, this is negative. So once again, if I apply the KVL, now I have flexibility that I can move in the loop in any direction. So let us move in the direction like this, means I will start with right, left, and then in this way I will move. Okay, so now here for Vm I am moving from positive to negative end, that's why I am writing minus Vm. For this diode I am moving from positive to negative, so that's a minus VD2, means the voltage across diode D2. For this diode I am moving from minus to plus, so that's why plus voltage across diode D3, that is VD3, right? Now what is this VD2? This diode is forward bias, So that's why it is almost 0, right? Actually it's a forward bias, so 0.7. What is this D3? It is reverse bias, so its voltage we are considering as a peak inverse voltage, right? So if I put this all values, what I am getting is, the equation is minus Vm, this is 0, so that's why I will not write, plus Vd3 is equal to 0. So ultimately this Vd3 is nothing but the PIV. So if I write the equation in terms of PIV, so I will be writing minus Vm plus PIV is equal to 0. So ultimately again you can see here is the peak inverse voltage across the dot D3 is nothing but equal to Vm.